Hi, everybody. So we did our research on partition testing, including equivalence classes and boundary analysis. And in our group, we have Brighton, Ethan, Irina, and Paul.
What is partition testing, or ECP? ECP stands for Equivalence Class Partitioning. It is a black box method of testing for functionality. It is dividing input or output data of a function into different partitions or sets from which test cases can be created. The elements inside one set can be treated equivalent to the other elements inside the same set in regards to testing. The goal of partition testing is to create as few test cases as possible while covering the most ground in the test cases. Partition testing can be used to test valid and invalid inputs and outputs. Equivalence classes and boundary analysis are closely related and are often used in conjunction with partition testing. Next slide. What are equivalence classes? Equivalence classes are another term for the partitions that a tester forms in partition testing. An equivalence class is representative of the range of inputs in a specific partition. The range of inputs of an equivalence class can be tested the same way, hence the term equivalence class. A test for one element in an equivalence class is a test for all elements in the same class. Any element in an equivalence class should expose the same quality assurance as any other element in the equivalence class. Thus, all elements in a class is just as suitable for testing all the others. Next slide.
What is boundary analysis? Programs that work tolerably for a set of values in an equivalence class fall short on some special values, which are often seen to be on the boundary of the equivalence class. Programming by character is prone to bugs at boundaries. When working with boundary value analysis, we play with the values on the boundary or just outside the boundary. Some boundaries are quite internal to the software and might not be apparent to the end user, but need to be checked nonetheless. Next slide, please. Types of boundary value analysis. First type is robustness testing. Its invalid values are selected and the response of the program is checked. Robustness tests focus on exception handling and is highly advocated when it needs to be checked. Worst case testing. Single fault assumption theory of reliability is that failures are rarely a result of simultaneous occurrence of two or more faults. But here we consider that failure is due to the occurrence of more than one fault simultaneously. It is generally used for situations where a high degree of testing is required. And then robust worst case testing is one of the special cases of boundary value. The difference lies in the number of test cases generated. It produces the largest set of test cases and requires a lot of effort. Next slide, please. And now let's talk about boundary analysis and equivalence partitioning testing processes. Next slide, please. Steps to generate test cases for boundary value analysis. First, find out values for each of the variables that should be exercised during testing from the specification, meaning that we divide the input domain using unidimensional partitioning. This leads to as many partitions as there are input variables. A different method is creating a single partition of an input sphere using multidimensional partitioning. Several subdomains are also formed during this step. Second, identify the boundaries and select values on or close to the boundary. And third, select the test data such that every boundary value occurs in at least one test input. Next slide, please.
The following are a few guidelines to follow when identifying equivalence classes. Number one, find input conditions that specify a range of values such as 0 through 10. Number two, find input conditions that specify the number of values, such as the user must enter 5 values. Number three, identify an input condition that specifies a set of input values that are treated differently. For example, an enumeration of different types of majors at BYUI Idaho. Number four, identify an input condition that explicitly states valid or invalid values. For example, a valid absolute value of a number will always be positive. Next slide. A way to identify test cases is to, number one, assign a unique number to each equivalence class, write test cases to cover as many valid classes as possible until all valid classes are covered under a test case. After doing those steps, then write individual test cases for every individual invalid equivalence class. And you do this for each individual invalid class so that all the invalid classes are covered and no invalid classes overlap another when testing. Next slide.
So one example of this is this simple math program. There would be 4 different partitions for this program or classes. X is less than or equal to 0. X is greater than or less than 10, or greater than 0 or less than 10. X is greater than or equal to 10 and less than 20. And X is greater than or equal to 20. We find these classes by looking at the code and determining that there are 4 different areas that need to be tested. When doing a boundary analysis, we can see that there are 4 different boundaries, 0 to just less than 10 and 10 to just less than 20. So a test should then be run for every boundary and equivalence class. So for our first partition or our first class, we run just a simple test to test outside the boundaries. For our second partition, we need to test both the upper and lower sides of the boundary as well as in the middle. And we do the same thing for our third partition. And for our fourth partition, we're going to test just outside the boundaries. This covers all of our boundary analysis as well as our equivalence testing.
Partition tests are very quick to implement programmatically. Testers know exactly what they're testing, as they need only test along clearly defined boundaries. As an added benefit, fewer tests need to be created as these tests cover a wide range of possibilities. Next slide. On the other hand, this kind of testing relies heavily on the knowledge of testers. A group of testers that is inexperienced may make assumptions which are not correct about the nature of correct values, and thereby not reap the benefits of using such a structured form of testing. Because only one test is run for each partition, extremely unusual edge cases could go unnoticed. The assumption made here is that because one input works for an equivalent class of inputs, all other inputs in that class will also work, which may not be true, depending on the situation. Next slide. Partition testing is excellent at testing predefined or pre-specified inputs and outputs, and as a result, is extremely quick and reliable. It is not a silver bullet and should not be used in every case. Testers need to know why and when they would need to use partition testing to be able to justify its inclusion. Because it is considered a black box testing technique, it cannot and should not be used to test the internal functionalities of a system. It is to be used only to investigate and validate the values being inputted into or outputted by a system. Next slide. These are our works cited. And several other sources we compiled.